It's nighttime if you drop your goggles in a 2.8 deep swimming pool. If you hold the laser 1.1 meters above the edge of the swimming pool, you can illuminate the goggles if the laser beam enters the water 2.2 meters from the edge. How far are the goggles from the edge of the swimming pool? So this is a swimming pool. We don't know how far the swimming pool is, but we don't need to know that. And from the edge of the swimming pool, the laser is 1.1 meters above it. And here, in the X direction, the laser is entering the swimming pool 2.2 meters. But you gotta take account that it's only the X direction. So the laws of refraction is that since the laser is coming from the air and is going to the water, that means the angle from the normal angle from the normal, it should be different from the angle in the water. So we need to know this angle from the normal. So we can use SOHCAHTOA here and down here. We can use the inverse tangent because we know the opposite side and the adjacent side will be right here. So calculating this, it will be 26.57 meters, which is equal to theta 1. But however, we only care about the normal angle because the laws of refraction says so. So we just subtract 90 minus, we subtract the 26.57 from 90, and we get the normal angle here would be 63.43 degrees. So this is the equation to calculate the laws of refraction, or the refractions between the air and the water, because they should be equal to each other. So here, this is a refraction of the water because the air, because the air has an index of 1, and the angle in the normal angle in the air would be 63.43 degrees. And here, you need to find the normal angle of this. You need to find the normal angle of the water, because since the index is greater than the air, this should be a smaller angle than this angle from the normal in the air. Is what I mean. So we rearrange this in order to find this theta. Rearrange it to put it here. So sine of 63.43 degrees divided by the 1.33, and it would equal to 0.6724. But then we use the inverse sine. Then we find the normal angle of the water that's in the next to a normal. So now we have everything to set up to find D, or D distance. So we just have to use the laws of SOHCAHTOA, or the rules of SOHCAHTOA, and rearrange it in order to find D. Since we know the opposite angle here, which, well, I can draw it here again, would be 2.8 meters. Be easier to read over here. We have everything to find what is D, since we know this angle, and we know how high the swimming pool is. So all we have to do is put tangent here, because tangent equals opposite over adjacent. The adjacent side will be 2.8 meters. Then use basic algebra. Rearrange it here. Put the 2.8 over here. Multiply by the tangent of 42.26 degrees, and we get the distance. The second part of the distance, which would be 2.54 meters. And since we know the initial x distance of the laser going into the swimming pool, we can just add the 2.2 meters to the D, then it would equal to 4.74 meters.